guys noticed about these two and these two? They're the same. And so that takes us to a logarithmic property that if you do log of x plus log of y, you can write it another way. So in this first case, this is x and this is y and this is what it matched. And then this is x and this is y and this is what it matched. So what are you doing to those numbers to get the other one? Multiplying. So that's the property. Log of x plus log of y is the same as log of x times y. So if you have two logarithms separated by addition, you can bring it together as a single logarithm where you multiply those two things together. Okay, so go ahead and do the second table if you haven't already, please. And see if you can figure out that property on your own. Oh, hold on, just kidding. Let's do number 3. So, sorry. How can you find a log of 30 if the 3 button is missing on our calculator? So we're going to do two logarithms where we're going to do addition. And we need these two things to multiply to get 30 but not use a 3. Yep. Very good. Okay. So now you guys try that second table for me, please. All right, so it happened again. These were equal, and then these were equal, and then these were equal. All of these have subtraction. And so if it's two logarithms subtracted from each other, what do you do with the x and the y? Divide. So you can bring it as one logarithm where you do 10 divided by 2 is 5. 28 divided by 4 is 7. Okay, so we're going to do the same thing with 30. We want to find log of 30. This time, we're going to subtract two logarithms to get it, and we aren't going to be able to type a 3. 60 and 2 is a good one. There's more than one that you could use, but it's a good one. Okay, and then 7 says that a student noticed that log of 1/2, which is what you guys did right here, gave the same results as negative log of 2. How is that possible? So, it is, but I don't think that's the reason. So if we are going to separate these, we have log of 1/2. We can rewrite it as log of 1 minus log of 2. So these properties work both ways. So if it's together as one logarithm, we can separate it into two separate. And so it's good if you guys can remember that a logarithm just gives an exponent. And so this is going to be whatever exponent is going to give you 1. So what exponent always gives you 1? 0. So this ends up being 0 minus log of 2, which is the same as negative log of 2. So that's how it's possible. There's lots of things that can be equal to that same value. All right. And then number 8, this is kind of a goofy question, but it's fine. So William was practicing evaluating logarithms on his calculator on Halloween. After he finished, all the calculations, he was startled at the results. He was sure that a ghost had haunted his calculator and broken it. What do you think? Can you make sense of the results, and is his calculator haunted? So what's weird is he typed in all these different things and got the same answer. And then on this side, same thing. All those different things and got the same answer. So let's see if we can figure it out. Something's weird with this calculator, if it's just logarithms. So to go from here to here, what could you do mathematically with those logs? This is more algebraic. Yeah, they're like terms. So log of 5 plus another log of 5 gives you 2. So this is just combining like terms. Which is perfectly fine. All right. And then the next one, there is a new property, the third property we're going to talk about today, where if you are multiplying a logarithm by something, like this 2, you can move it up to a power. So that's the power property of logarithms. We'll squeeze it over here on the side. If you have log or a log of x, you can rewrite it as log of x to the a. All right, because you got the exact same thing, exact same answer. All right, and then they squared the 25 or the 5, and that is 25. This next one, I kind of wish it was in a different order. So 1/2 log of 625 also gives you that same decimal. So let's see if we can make that make sense. So I can take that 1/2 and make it a power of 1/2. What does it mean to raise something to the 1/2? Square root. So that right there is the square root of 625. Is that 25? Yes. So that's why it all works. So it all checks out. Nothing weird happening on that side. Now I know you guys don't have a great copy, but I think we can do the other side as well. So we had a log of 4 plus a log of 4 plus another log of 4 gives us 3 of them. Combining like terms, no big deal. A number multiplied in the front can get moved up to a power. That's fine. 4 cubed is 64. Is 64 2 to the 6? Yes. And then now you can just take that 6 and move it down in the front. And so it all checks out. No haunting. It's just log math. Sometimes math is scary, you're right. All right, and then for number 9, we're going to write 2 more log statements that are going to be equal to this 1.806. And we can use any of our properties that you want to. Anyone have one? It might be easiest if we work with this and try to rewrite it with a 64.
Log 8, log 8.
Yeah.
Yeah, that's awesome. Oh, wait, couldn't you do log 8 to the second power?
Yeah, both of those. Those work perfectly. So let's do. We could do tons more, but those 2 are perfect. Thank you guys for participating. No, we're not. It's okay. This box is way too big for all the stuff we have to write, which is good. It's usually just the opposite. We're squeezing it in there, and this one we have plenty of room, so that's good. Okay, so let's just rewrite these properties on this side so we can use them as we do our examples. So the first property is if it's the property of addition or the product property, depending on which way we're looking at it. But if we have 2 logarithms that have the same base that are added to each other, we can bring them together as one logarithm with that same base, but they're multiplied by each other. All right, and then if we have 2 logarithms that are subtracted, we can write one logarithm with division of the x and the y. And then the last one, if I have a logarithm that's multiplied by a number in the front, I can move that number up to a power. Now in this class, a lot of times what we are learning, you already learned in Algebra 2. This is not one of those times. In Tennessee, they took the property of logarithms out of Algebra 2 and stuck it in pre-calculus only. So this is going to be the first time that you're learning this. So if it seems like you don't know it, it's okay. It's because you've never done it before. All right, so when you're told to condense, you're going from multiple logarithms to one logarithm. So this is the order that you're going to use the properties in. And then when you're asked to expand, you have one logarithm that you're going to make multiple logarithms. So you can use the properties in the other order also. All right, so let's do a few examples with these. So for number one, every little thing that is getting multiplied gets its own logarithm. So how many different items or factors are being multiplied on A? 3, the 5, the X, and the Y. Each one of those gets its own logarithm. So it's like Oprah is giving out logarithms. Everybody gets a logarithm. So, yeah. So we're going to start with log base 4 of 5. And then because these are all multiplied, we have no division bar. It's going to be all addition. So then plus log base 4 of X plus log base 4 of Y. That's how you expand. Everything gets a logarithm. All right, and then for B, how many logarithms are going to be handed out on B? Also 3. 4 gets a logarithm, W gets a logarithm, and 7 gets a logarithm. This one's a little tricky because you have a combination of multiplication and division. And all that means is you're going to have a combination of addition and subtraction. And so what I always tell my pre-calculus students is if it comes from the numerator, it's going to be a positive logarithm in the front, kind of like a positive exponent. If it comes from the denominator, it's going to be a negative logarithm. So the 4 is in the numerator, so it's going to be positive natural log of 4. The W, also in the numerator, plus natural log of W. Right, and 7's in the denominator, so minus natural log of 7. So you can use multiple logarithms in one problem. We could actually use all 3. They could have made this more difficult and made it like W squared. And then that square you'd have to bring down in the front, but it's okay. Okay, so on the next one, we're going to condense. So we have multiple logarithms we're going to bring together as one. So for that addition, we can either add them or we could use the property and bring it together using subtraction. I don't know which is the easiest one. Okay, so if we add them, that's going to give us 2 of them. What? Yeah. Yeah, it probably is easier. Since they're like logarithms or like terms, we can add them together and get 2 of them. And then if we look back up at our notes in that box, these directions are to condense. And when you're condensing, a logarithm or a number that's in the front needs to get moved up to the power. So that's the last thing we would do is take that 2 and move it up to a power of 2. And that's going to need to be your final answer. All right, and then when we go to do B, we're going to start off with that. So we can't bring these together right now because that 2 plus 2 is in the front. So we're going to move that 2 up to a power. Right. And then since these logarithms are separated by subtraction, what are we going to use to bring them together? Division. So a single logarithm, in this case, I'm going to go ahead and make it 25 in the numerator and 4 in the denominator. All right, y'all okay? Okay. And then the next one wants us to figure out which one is not equivalent to log of 16 or it's possible they're all equivalent. So you guys look through those and you decide which one is not equivalent using the properties. And you don't have to use the log button in the calculator. You could just move that to a power and see if 4 squared is 16. If it is, then it's equivalent. You can just multiply those and see if it's 16. If it is, it's equivalent. So what do y'all think? They're all equivalent.
What do you mean?
On A, if I take that 2 and I bring it up to power, it's log of 16, which is what we want. Tricky question. It's a way to get you to do 4 problems, and it just looks like it's 1 problem. I know. All right, and then this last question is about Tori. So Tori was asked to rewrite log base 2 of 32a cubed and then simplify. Her work is shown below. In which step did Tori make her first mistake? So let's see. We started off, these two are multiplied and separated by addition. Is that right? Absolutely. All right, and then she said that log base 2 of 32 is 5. For that to be true, that would mean that 2 to the 5th is 32. Is that true? It's true. I think so. You're making me question it. 100% true. So that one's fine.
It just didn't sound right in my head.
Maybe I asked it in a way that made you want to say no. All right. Yeah. And then the next one, she took this 3 and she moved it down in the front. Is that okay? It is. All right. And then the last step, she added and got 8. That's a problem. What's wrong with that? We really can't do anything else at that point. Yeah. This is the simplest form. She should have stopped right there. So to be able to add, it has to be a situation like we had here where they're like logarithms. They look exactly the same and we could get 2. But to add 5 in a log, that's not possible. So it was step 4. Cannot add because they are not like terms. Okay. What questions do you guys have on the properties of logarithms?
On the fraction ones, can they be involved fractions at all? Like the one out front, you have
Like 7 halves or something like that? Yeah, that's fine. Can be any real number out there. All right. What other questions do you guys have?